welcome back to my channel. Do you know that calculus is of 3 arms? They are the limits, differentiation, and integration. In our today's tutorial, we are going to discuss differentiation. It may also interest you to look at our previous tutorial on limits. The link I will leave in the comment section. Now relax. Remember, this is a home where math is made simple. If you're ready for today's class, let's work it out on the board. Now the question is, what is differentiation? Simple. It simply means the rate of change of a function. What it means is that differentiation is also the gradient or the slope of a function at any given x value. That you will see more of in our solvers. Okay, are there other ways we can use in place of differentiation? Yes, they are. You can call it the derivatives. You can also call it the differential coefficient. Remember, we said it is the gradient of a function at any given x value, meaning that we can also call it the gradient or the slope. Okay, now consider this particular function. Let's take it that we are given this function, say y is a function of x. Its derivative simply means, since y is a function of x, to get its derivative, you are going to have dy by the x. This is read as dy dx because a function of x, y is a function of x. So this is how you represent it if you are finding the derivative or the differentiation of this particular function. You can also represent it like this: d dx of f of x. This means you are finding the derivative of this particular function. You can also represent it like this: f prime of x. It also means you are finding the derivative, but remember, because it's 1 prime, it means it is derivative of the first order. That means differentiate once. So if I want you to differentiate 2 times, I will put 2 primes and have this. That means you are differentiating it 2 times. Now this can also be expressed in this form, meaning you are differentiating y, and this differentiation is also of the first order, and so many of them. Okay, now that you understood all this, supposing I give you s as a function of t, s as a function of t, how do you express it if you are finding its derivatives? Since s is a function of t, it will now be ds by dt. That's ds dt. I hope that is clear, and so many of them. Now let's look at how to differentiate simple terms. Join us as we do. Let's look at how to find the derivatives of these questions on the board. They are very simple, okay? These are simple terms, and you know, when you know how to get simple terms, their derivatives, it makes it much easier for you to solve those ones that involve expressions. Now let's do this together. Remember your power rule in differentiation, which says that if y is given as x to the power of n, according to your power rule, it means that, remember, this is a function of x. So it means that your dy dx will be equal to the key, multiply and remove. Let's take that again. When you multiply, you remove. So let's do it together. So we're going to multiply the power with the coefficient of this x. Remember, the coefficient here is 1. So we are going to multiply it with 1. And when you multiply n with 1, it gives you n. Okay, so it means that in multiply we are going to have n then you remove 1 from the power. That is the key. Multiply and remove. So use the power to multiply the coefficient of your x, then remove 1 from your power. We call this the power rule, and that will be our guide. So this is the power rule which we are going to use in answering this question. Now let's start it with the first one. We are given 2x. Remember, this simply means that y is equal to 2x. I hope that is clear. Now if we are asked to find the derivative of this, what do we mean? It means that, remember, when you have 2x, it means that x has a power which is 1, according to your algebra. A letter without a power has an invisible 1 as a power. So the power here is 1. According to our rule, multiply and then remove. So we're going to use this 1 to multiply our 2. So if we are solving that, we are now going to change it to dy dx. Because this is a function of x. So we're having dy dx is equal to 1, we multiply 2 to give us 1 multiplies 2 is 2. So we're having 2, then 2x, remove 1 from here, from the power, multiply and remove. So we remove 1 and 1 minus 1 is giving us 0. So this means we are going to have this. And you know that anything raised to the power of 0 is 1. So what it means is that this will give us 2 multiplies 1 and our answer is 2. So it means that if I'm differentiating 2x, I'm going to have 2 as an answer. Let's look at this. This is negative 4 over 5 t, and we are asked to find its derivative. This is a function of time. Okay, so we have s is equal to negative 4 over 5t. So in our differentiation, this has a power of 1, which we use to multiply. So if you do that, you are going to have the s dt is equal to, if you use 1 to multiply, negative 4 over 5, it gives you negative 4 over 5. So we're still going to have negative 4 over 5t. If you subtract 1 from this, it gives you 0, and that is t to the power of 0. And t to the power of 0 means 1. So it means that our answer for differentiating this is negative 4 over 5. What do you observe? You observe that when you have a term that its power is always 1, when you differentiate it, the answer is always the coefficient. Please note it down. Whenever you have a term in this form that has an unknown whose power is 1, each time you differentiate, the result is always the coefficient. If you look at this, our answer gave us 2, which is this coefficient. If you look at this, our answer gave us negative 4, which is this coefficient. Now let's go to the example 3. Y is equal to x squared. So in our power rule, multiply and remove. So we are going to have dy dx is equal to, use this to multiply, we have 2x, remove 1, and 2 minus 1 is 1. So it means x to the power of 1, and x to the power of 1 simply means x. So if I differentiate this, I'm having 2x. Now let's move it to this. If you differentiate, we are going to have, this is s is equal to negative 5 over 6t squared. So in our differentiation, I'm going to use this power to multiply, and that will give us the s dt is negative 5 over 6 multiplied by 2. Then t to the power of 2, you subtract 1. And 2 minus 1 is giving us 1. So we have 1, and anything raised to the power of 1 is that number. So what it means is that we are going to have this over 1, this we cancel 1, and this we cancel 3. So our answer becomes, we are going to have for this, it will give us negative 5 over 3t as the value of this particular question. Now for number 5, we are having y is equal to 5. What does it mean? This is a constant. So it doesn't have a letter or the unknown with which we are going to use the power rule on. But we can change this to something and we still do not make any mistake. Remember, y equal to 5 means 5x to the power of 0. Because x to the power of 0 is 1, and 1 multiplies 5 will still give us back 5. So what it means is that this is what we have, and if you are differentiating, we are going to use this to multiply. It gives us 0 multiplies 5 is 0, and anything multiplied by 0 is 0. So what it means is that our answer here is giving us 0. And what does it mean? For differentiating this 5 as a constant, it gave us 0. Let's try this. This is also a constant. So whenever you have a constant, it means that if you differentiate it, it is always what? 0. So if this is a constant, without wasting our time, the y, the x will give us 0. Okay. Now let's go to number 7. We have this. So we have the y, the x is equal to use the power to multiply. 5 multiplies 3 is 15x. Remove 1 from the power, it will give us 2. So this is what we get in differentiating. For question 8, we are given y is this, then its derivative will be equal to, I will use the power to multiply. So use this to multiply this, it gives us negative 4.5. Then we have x, take 1 from here, we are going to have 2. So this is what we have. Then for this is a rational term. Remember, we are using power rule. So our duty is to change this ratio to an index for us to use this rule. So if we should do that, we are going to have y is equal to, according to your indices, 1 over a is the same as a to the power of negative 1. So in this case, we are having y is same as x to the power of negative 1. So each time you have ratio, change it to index or exponent. So we are going to have this, then let's differentiate. We are having dy dx is equal to, use the power to multiply, negative 1 we multiply to give us negative x. Then take 1 from the power. If we take 1 from this, it will give us negative 2. So we're going to have negative 2. To return it to be in a ratio form, remember x is having a negative sign, so x will come down. This will give us negative 1 all over x to the power of 2. This is the same as this. Okay, so this is what you get for differentiating. For this, what do we do? Let's go to the number 10. For number 10, we have x is equal to this. Still rational. As we said, change it to index. So we're going to have x is equal to negative 6. Remember, this means negative 6 is multiplying 1 over t squared. That is what this means. So that if I can multiply it, this will multiply to give me this, and this will multiply to give me this. So I will get back this. So what this means in the other way around is that if I should express this in index form, it will give me negative 6 is multiplying this. And this in index form is giving us t to the power of negative 2. So in that case, we are going to have this whole will give us negative 6t to the power of negative 2. I hope it's clear. So let's differentiate. Use the power to multiply, remove from the power. So negative 6 multiplies negative 2 will give us 12. So this is going to give us, so we're having the s dt will give us 12t. Remove 1 from the power, we are having negative 3. T is having a negative sign. It means that t has to come down. So we're going to have 12 goes up. It will now be 12 over t to the power of 3. So this is what you get for differentiating this function, this term. Let's go to the number 11. We have y is equal to this. Please note that this is not the same as 1 over 4x. Very important. Okay, now that you have watched through this point, it shows that what we are doing interests you. Please don't forget to subscribe to us. Support this channel by subscribing to us. Let's know how you feel about what you are doing in the comment section. Give us a thumbs up and share this video with your friends and family. Hopefully you have done that, and let's continue. Thank you. So we are going to have, remember this and this are not the same. In this, x is at the denominator. Here, x is serving, this is serving as the coefficient of x. So they are not the same. So let's go to what we are given. This is what we are given. So this means it is the same as 1 over 4 is multiplying 1 over x. So that 1 multiplies 1 gives us 1, and 4 multiplies x gives us 4x. So if I should express 1 over x in index, it means it will be x to the power of negative 1. So what this means is that y is equal to 1 over 4 x to the power of negative 1. So that is what we have here. So in that case, we clean this off and we say that this means 1 over 4 x to the power of negative 1. Now let's differentiate. So we're going to have dy dt, the x is giving us, use this to multiply, we have negative 1 over 4 x, subtract 1, we have negative 2. X is having a negative sign, so it goes down. So we are going to have 1 negative 1 over 4 is multiplying 1 over x squared. So what it means finally is that negative 1 multiplies negative 1 will give us negative 1. 4 multiplies x squared will give us 4x squared. So this is what we get for differentiating. Okay, let's go to the number 12. This is a radical term. And remember, we are using power rule. So for a radical term, we are still going to express it in exponents. So remember in your exponential rules that root means what? Power of half. So in that case, our y is equal to x to the power of half. So to differentiate this, we are having dy dx is equal to, use this to multiply, we have half x, take 1 from half, and that will give us negative half. So to return this in radical form, we are going to have, this will give us 1 over 2 multiplies, this is same as x is taking negative, so it will be 1 over x to the power of half, which is the same as, if we should clean this, it will be our radical sign, which is this. So this means 1 we multiply 1 is 1, and this will give us 2 root x. So this is what we get for differentiating. Now let's move to the 14th one. For the 14th one we have, okay, let's take this. For this we have y is giving us this. Express it in index or exponential form. This is the same as 2 over 1 is multiplying 1 over cube root of x. That is what it means. So let's express this in index form. It will give us x to the power of negative 1 over 3. This will give us x to the power of negative 1 over 3. So it means that for this, we are going to have 2x to the power of x over 3. So this is what we are going to differentiate. And in differentiating this, we are going to have dy dx is equal to, use the power to multiply. So we are going to have negative 2 over 3. Okay, x to the power of negative 1 over 3, take 1 from it. So negative 1 over 3 is the same, minus 1 is the same as 3 over 3. Okay, so we are going to have negative 1, negative 3 will give us negative 4. Negative 4. So we are going to have negative 4 over 3. So what it means is that this is giving us, let's clean this. This will give us dy dx as negative 2 over 3x, negative 4 all over 3. If we should return it to be in radical form, we are going to have negative 2 over 3 is multiplying 1 over x to the power of 4 over 3. Remember, you use the denominator to form the roots, so we are going to have cube root of this to the power of 4. So this will give us negative 2 over 3, then cube root of x to the power of 4. Then finally, for this, in index form, it will be 4x to the power of negative half. Okay? So to differentiate, use the half to multiply, and that will give us 4 will multiply negative half to give us negative 2. Okay, so we are going to have dy dx will give us, if you multiply, it gives you negative 2x, subtract 1, we are going to have, this is same as 2 over 2, so negative 1 minus 2 will give us negative 3 all over 2. Okay, so that is how to differentiate some of these simple terms, both in their rational forms and in their radical forms. I hope what we did today really answered your question. Please, if it does, and if it did answer your question, don't forget to give us a thumbs up, support this channel by subscribing to us, like us, and share with friends and family. Don't forget to leave your thoughts with us. It helps us to serve you best. See you in our next class, and bye-bye.